Data type 3 has some terms that are associated with it, which are useful for making its calculations. We need to consider, we have to have put it in our mind that data type 3 is a big deal from WASI. So it depends, it builds upon on data type 1, data type 2, and we have explored that, and we've seen the logic behind data type 3. Now we need to understand some terms associated with data type 3, which are useful for its calculation of the various tools like mode, median, central tendency, and those stuff. So we are going to look at those basic terms. There are about 4 of them, which we are going to explore. So we will explore that through examples, so that you can relate what each of the terms mean. The very first term that we associate with we'll try to explore is, so we are going to use this example, right? This example from the previous session, that will help us to transport something from the type 1 to the type 3, where we understood the logic. So this time we want to understand some terms so that we can use them when we are doing the calculations on mode, median, and stuff. So the first term that we are going to do, we are going to understand first, we need to understand class. In data type 1 and 2, we were calling the items item. For data type 3, they are in ranges, right? So in ranges, because they are in ranges, instead of calling them item, because it's not a single individual there, they are a group of items there, we call them classes. So this is a class. Class mark, class boundary, class age, whatever. So these are the classes. So 0 to 10 is a class. 11 to 20 is another class. Each of them is a class, right? And you can see that each of the classes are in range. So, and then there are values that are associated or that define that bracket of numbers in that domain. So what are these terms or these numbers? How are they referred to? For example, let's take the first one. The first class is 0 to 10. So the 0 and the 10, they should have a name, right? They should have a name probably. So the name, because it's a class, right? And the ends, we are going to call them the limit of that class. So we have the beginning limit and the ending limit for each of them. Because of that, because it belongs to a class, it is called class limit. So each of the ends are called limits, the class limits, right? But the one that is the first one, we call it lower class limit. So lower class limit, and this one is upper class limit. Yeah, so what do they do? As the term says, they limit the range, they limit the class, they define the edges of the class, 0 to 10. And then if you come to 11 to 20, which is the second one, you see that 11 is the lower class limit and 20 is the upper class limit. Why? We don't call them items again, we call them class when we are in data type 3. Data type 2 and 1, we can call them item, we can call them the age, but if you come to data type 3, they are called class. If it's a mark, the items are marked, we call them class marks. Okay, so, and we have just defined that, okay, for each class, there are terms associated with the item that define the limits. So the upper class limit is the end, and then the starting in the lower class limit is lower, and the end is the upper. Makes sense, right? So those are the things that we will see in your book. We don't end it there. We need to actually come with an understanding that usually this term move from one to another class. So you can move from one class to another class to another class to another class, right? But let's look at this as in terms of countries like Ghana and Togo. Ghana and Togo, right? There's a boundary between them. Right? But that boundary between them is not like, so if you have, let's say you have Ghana here and you have Togo here. So we have a boundary here. Let's say this is the boundary between them. We have this boundary between them, right? Now, for the classes here, what's happening if you move from 0 to 10, right? If you move from 0 to 10, what's happening is that if you are moving from 0 to 10, before you go to 11, there's a difference of what? 1. Meaning there's a small space. Between them. So the space between them, in terms of the country that I'm trying to make you understand, is just like They are not connected, but there is a small space between Ghana and Togo. Right? There's a small space between Ghana and Togo. So that small space in terms of the numbers is the difference, which is 1 in this case, right? But actually the countries are connected, they are bounded, right? So there's a boundary between them. It's not like there's a space before you, so you don't have to jump over something to get to. You don't have to jump. There's no space between Togo. Yes, a boundary, something that's putting the difference. So they are connected by a common boundary, right? So where Ghana ends, that's where Togo starts. Just an analogy, right? Where Ghana ends, that's where Togo starts. So that's the same thing happening with the classes, right? Where this class ends, it's as if you have to jump over by an item of 1 before you get to 11. But actually, we can bind these classes together such that the ending of a class, right, or the first, if the first class ends, you can take it, the next class can take it from where the previous one ends. Not like when you reach 0 to 10. When you reach 10, now you have to jump by 1 unit before you go to 11, and then the next one takes it from that 11. We can bound them together such that when 0 to 10, then the next one will take it from that 10 going. It's not that easy. You don't have to just go and change them, but you have to follow something. So we are going to do that immediately right now. Um, let's let's use the first class 0 to 10 and 11 to 20. In this case, they are class limits, right? They are class limits. All of them are class limits. So this is a class. So this is a class, right? By which class? Class limit, class limit, class limit, because they are bounded by limits. But we need to change them to class boundaries. The boundaries means that where the previous one ends, the next one takes it from there. But how do you do that? This is what you have to do. We have to find the difference, right? Because that is the difference that is causing the thing. The difference between this and this. The difference between this and this, we said is one, right? To put them together, right? You just find the average of this one. So you just 1/2. So you divide this 1 by 2 so that, okay, it's like we have one difference. But instead of having one as a gap between the two countries or between the two separate classes, what we have to do is that difference, we can divide it into 2 and give 1 to Ghana and give 1 to Togo so that they can come together. So we give 1 to Ghana and give 1 to Togo so that the two of them can come together, right? So to bring, so let's talk about this limit. This is what connects to the next class. I'm talking about these two. So at the end of the day, so if you have the difference to be 1, right? 1/2, if you have, which is 0.5, right? So to put them together, to put the 10 and 11 together, so that when one and the other one starts, what we have to do is that we do 10 plus 0.5, and for this one we do 11 minus 0.5. What do I have there? So over here I have 10.5. If I do here, I have what? 10.5. At the end of the day, I have 10.5 and 10.5. So 0.5 here minus 0.5 at the other end. That's what we do basically, right? So to put them together, at the end of the day, the first class that we have will be 0 to 10.5, and the next class will start from 10.5 to 20. Do you see that? Now, where the first class ends, first class ends, the second one continues from the same 10.5 to 20 instead of doing 11, instead of starting at 11. So it's as if, okay, it's as if they are just a list of items that's continuous. So you make them continuous now so that there will not be any difference. You make them continuous now. This form of the class, right, where you are able to make it such a way that where one class and the next one takes it from there and continues, this kind of class we call a class boundaries. Now they are now bounded like the countries, your country boundary, like the border. So we call it class boundaries. So for class boundary, the same thing. We have lower class boundary and upper class boundary. Lower class boundary and upper class boundary. Do we follow that? That's the logic behind. The thing is, we need to understand the logic behind what we are doing. So when a lower class limit, so limit it, so there's a difference. But when you're talking about boundary, you need to make sure that you put them together. So find the difference, you divide that difference by 2, where you now add the what you got from you add what you got from the previous class and you subtract that from the next class or the continuous class. That's what we did basically. So let's use that on all the data here. Then let's see. So if you can change this to class boundaries, you can change the classes to class boundary, right? But the frequencies remain the same under them, right? So what we do basically, so the first one is 0 to 10, right? 0 to 10, but the difference is 1, so we become 0.5. The next one become 10.5 to 20. I mean, the same classes, so I'm just continuing the table for you. The same classes, 20. Now 20 and 21 is the next one. 20 and 21. Now 20 and 20, the difference between them is what? 1, right? So 1, we do the half of that one, which is also 0.5. 0.5, 20 minus 20 become 20. 20, because 11 to 20 is the class, is the previous class, and the next class is 20 to 31. So if you do the difference and you half it, you add it to the previous class and you subtract it from the next class. The coming class will have to pay something, and the going class will have to get that bonus, right? So we have half here, so we become the class going, which is 20.5, is become 20.5, and the next one 21 minus 0.5 will also give us what? 20.5 to 30. If you go here to, you see that the difference is still 1, so become 0.5, 30.5 to the same thing, 40.5. You do the same exercise for all of them. This one 40.5 to 50.5. Then you go like that. These forms of them are called class boundaries. Now you see that for each of the classes, we did the difference between the lower class boundary and the upper class boundary. Difference between lower class boundary and upper boundary, and do some subtraction and addition, right? So the class that is going, we add half of what we got as from their difference, right, to that, and the class that is coming, the beginning, we subtract 0.5 from it. Then we do that for each class. So we do that at the boundaries for this previous class, next class, previous class, next class starting. So the previous class ending and the next class starting, we focus on them and do the difference, find half and add to the previous one and subtract from the coming one, like that. That's what we do throughout. Are you good? But then the beginning and the ends, what then happens to them? The beginning and the end, what then happens to them? Does it mean that, I'm talking about the first class. We didn't do anything to the 0. And then if you get to the end, you see that you have 60.5 to 70. So it's as if the ends, they don't undergo any different, because yes, there's no other country coming, right? Or there's no other um, class coming for them to do the difference. But what we have to do is that, because this one doesn't have a beginning before them, and then the east ends has undergone an addition of 10.5, right? So what you have to do is that you just come here, the first one, you actually subtract the 0.5 from it. Yes, you subtract the 0.5 for it, to make sure that the class size remains the same. We'll talk about the class size in the next session, right? We'll talk about the class size and then the midpoint, which will be in the next term that we'll be evaluating. So this time I just want to take the exercise to understand how class boundaries work. Are we good? So what we have to do for this case is that, hey, we just, instead of using, let me so 0, right? We added 10.5 to each upper one boundary. Remember, this one, it doesn't have a previous class. That's why we are just focusing on this for now. But the rest, we do the same exercise. So, but this one doesn't have a class before it. So something should happen to the beginning also. So 10.5, right? 10.5, we added what? 0.5. So what we have to do to balance, to make sure that the class size, that we are going to subtract 0.5 from this one. So 0 minus 0.5, we are going to have negative 0.5. So actually, what we should have at the beginning here should be negative 0.5. That is starting. This is not a dash, this is a negative. The frequencies are the same. So negative 0.5 to 10.5. The same thing will go to the end. This one, 60.5. What do? We subtracted, it was 61. We subtracted 0.5, right? So because it's the end, right, we need to actually do 70.5 to add to the end. Yeah, that's basically what we do with that. What we do with that. You can make sure that we have a class boundary. Yes, that's what I want us to take from this session, where we try to understand how the simple terms, especially the class boundary and class limit, so that we get the difference, right? We'll be using these terms when we are doing the calculations using the tools like mode, median, right? So it's good to take time, go back if something doesn't make clear, it's not clear to you, go back, rewatch it, and then put your worry in the comment section. Then we'll get back to you. Next session, we'll try to also continue with understanding some terms again, class size and class midpoint, and how to get them from the class limit and class boundary respectively. We'll see that in the next session.